Let's begin. Welcome to today's webinar on generative AI, trustworthiness at the C-inspection approach. Thank you for joining us. My name is Elizabeth Hild. I'm the director of the Ethics Center at the Illinois Institute of Technology, and I'll be moderating this webinar. It's my great pleasure to introduce today's speaker, Dr. Jesmin Jahan Tithi. Dr. Tithi is an AI researcher at Intel Corporation. She's a leading expert in high-performance computing and hardware-software co-design. She holds a PhD in computer science from Stony Brook University, New York. And Dr. Tithi is a founding member of the C-inspection initiative, an international group of researchers who is developing a process for assessing trustworthy AI. Both she and I have been part of this group for a number of years now. I'm really glad that Jesmin agreed to give a webinar presentation today. So the floor is yours, Jesmin.
Thank you, Elizabeth.
Go ahead.
Introduction. I hope everybody can hear me fine. So welcome everyone in this talk on harnessing inspection for trustworthy AI. I am a founding member and head of education for North America and a certified teacher for inspection and also part of inspection initiative. You may have noticed there is a R on top of inspection, which means the keyword inspection is registered trademark. However, the content of this work is available for open access under the license of Creative Commons and can be used for non-commercial purposes. Let's move. Okay. So I'll turn off my camera so that you can focus on the presentation for now. Let's see. Okay. I'll start with a disclaimer that my primary research focus at Intel is high-performance computing, parallel algorithms, and software-hardware co-design. And this is not related to inspection. I worked on inspection to pursue my own interest on ethical AI, and thus the views expressed in this presentation are my own and do not reflect the official policy and position of Intel Corporation. Is there this ribbon visible, or should I, let me, you can see my screen properly, right?
Yes, everything is fine.
Okay, great. So let's get started. The first question that I'd like to answer or ask is, what is generative AI? Generative AI, or GenAI for short, is a branch of AI that utilizes machine learning algorithms to generate new data. And the data could be anything from realistic images, videos to musical pieces, software programs, exam essays, medical treatment suggestions, creative text, media, even cooking recipes, travel plan, New Year resolution, you name it. The chart in the bottom right shows how GenAI is related to AI, ML, and deep learning. As you can see that GenAI is part of deep learning, which used to be trained on large amount of data. GenAI models are also trained on massive data sets of existing data, allowing them to identify the patterns and relationships of all human knowledge ever digitized. By leveraging this knowledge, the GenAI models can then generate new examples that will adhere with those patterns. And the generated data is so realistic that it's very convincing to human. The potential benefits of generative AI are vast and transformative. For example, they can accelerate drug discovery of new life-saving drugs by simulating complex molecules. The DeepMind's AlphaFold that won Nobel Prize last year is an example of that. GenAI can design innovative materials with unique properties, leading to advancement in fields like clean energy. They can assist artists, musicians, and writers to create new creative contents. GenAI can be used to make coding and designing new hardware easier These days, we often use GitHub Copilot to help in coding, and that's an example of that. GenAI can be used to generate new educational content, improving writing and grading. They can personalize experiences from tailoring educational content to recommending products. They can be used to create highly realistic simulations to train self-driving cars and other form of autonomous agents, such as robots, improving their safety and performance. And it can increase productivity for those who can use them well. I have seen numbers like 30% to 10x productivity increase by use of GenAI. So there are tremendous opportunities of AI to become a digital assistant to most, if not all, human endeavors. AI has democratized the use of high-performance computing, which is my other research area, which was exclusive domain of elite research lab until recently. And ChatGPT is a good example of this, that how HPC has been democratized, providing benefits to all individuals in the society. So GenAI has brought power to all. However, with great power comes great responsibility. And we need to be responsible as users of GenAI, as developers, and as deployers. Now, despite its potential, generative AI presents several ethical challenges. One of the biggest ethical challenges is the bias. GenAI models that are trained on biased data can perpetuate and amplify existing societal biases. So, say ChatGPT has been trained on the entire internet or all the data that they could get. And we know that society is not fair, and oftentimes the internet is reflecting the views of the majority and not the minority. So the model that has been trained on such data will only replicate the voice of the majority, but not the minority. GenAI can hallucinate, which means it can produce wrong or incorrect information, and can be dangerous to use in certain safety critical use cases or sensitive use cases. I'll show you an example soon. And if the data that is used to train the GenAI is outdated or irrelevant or insufficient, then the information that will be generated could also be outdated or irrelevant. Until recently, ChatGPT would say the data it has been used to train is on for this up to this date, and then any information that it will generate will not capture the information that has happened after that time. Nowadays, there are ways to reduce both hallucination and problem with outdated data, such as retrieval augmented generation, also called RAG for short, or now the GenAI model can also use search tool to search for latest information in the internet and then use that also to augment its result. However, we can still guarantee that the output is 100% accurate. So we have to be careful. The ability of GenAI to create data that closely resembles real information also raises privacy concerns. Copyrights might be violated when using generated content, especially for those GenAI that has used copyrighted material in its training data. There are a lot of issues that got raised because the code that was generated by GenAI was using code sample that has particular copyright, but the GenAI model, when it produces the output, doesn't mention about the copyright. So we have to be careful when we use the generated data from GenAI. And GenAI can create realistic but fake videos and audios, which can be potentially used for malicious purposes. For example, last 2 years in global elections, we have seen reports of these fake images being used for election engineering as well as social sentiment analysis. Here's an example, funny example of hallucination. So last year, I asked Gemini, which is the GenAI model from Google to, provide me some latest paper on a particular topic. And it gave me the title and the conference name. So I went ahead and, looked for the paper, and the paper does not exist. So then I, told Gemini that, you were hallucinating, and it said, oh yeah, you were absolutely right. So you cannot use this tool for research because they can produce paper name which does not exist. Some other problems, lack of transparency. The inner working of complex GenAI models can be opaque, making it difficult to understand how they arrive at their outputs. Recent models, especially the reasoning models like the DeepSeek model that came in last December or January, it shows its thought process. So at least we understand how it came up with its output. But most of the other models, they don't show, and it's often very difficult to understand how the model produced its output. As people use more of it, there is a potential of descaling in certain areas of task. I think if we use GenAI tool to do most of our writing, we might, we might lack some of the skill of writing over the time. Also, as GenAI automates tasks currently performed by human, job displacement becomes a significant concern. We are seeing a lot of layoffs last 2 years, and we can blame GenAI at least, partially for that. It also takes millions of dollars to train large foundational models, and only a few companies can afford it, creating a potential for concentration of power, which is dangerous for democracy. Also, it's not only costly to train large language models or large generative AI models, it is also very harmful in terms of carbon footprint. Training GPT-1s emitted the same amount of carbon footprint as traveling to moon. So we have to be mindful about these impacts as well. Now, here's a potentially problematic example. Last year, Texas said it will hire 2,000 graders instead of usual 6,000. And by doing so, the state will save as much as $20 million per year, eliminating human jobs. Another example that caught my eye was that Apple's research team released Ferret UI that allows LLM to access and understand what's on your screen. Now, it can be useful for certain cases. For example, people with disability of seeing can be using this feature. However, I see a lot of privacy concern in this use case. Now that we know what is GenAI and some of the positives and negatives, let's talk about a process that can help us to assess these positives and negatives and improve the trustworthiness of AI. And that's what inspection is. The inspection is a practical assessment process for trustworthy AI, which is based on applied ethics, can be applied to a variety of domains that includes business, healthcare, public sector, education, and many others. It is customizable based on the use case, domain, and context. And it allows to use existing frameworks, checklists, and tools as plugins. The inspection can be utilized at various stages throughout the life cycle of an AI project, such as design, development, deployment, and maintenance. It focuses on identification and discussion of ethical issues and tensions through the elaboration of socio-technical scenarios. And I'll talk about it later in the presentation, what it means by socio-technical scenarios. It uses the general European Union's high-level expert group's guidelines for trustworthy AI and shows how this guideline can be used in practice to do the assessment. To assess whether something is trustworthy or not, we have to first define what does it mean by trustworthy. And the inspection uses use guideline for trustworthy AI, and according to them, to be trustworthy, an AI needs to be lawful, respecting all applicable laws and regulations. It has to be robust, both from technical and social perspective, and it also has to respect all ethical principles and values. And they gave 4 ethical principles, and these are respect for human autonomy, prevention of harm, fairness, and explicability, which means explainability. They also gave 7 requirements of trustworthy AI, which means, according to them, to be trustworthy, an AI system needs to satisfy these 7 requirements. And those are human agency and oversight, which means respect for fundamental human rights in the AI system, and making sure that human is in the ultimate control. Technical robustness and safety, which means resilience to attack and security, fallback plan and general safety measurement, accuracy, reliability, and reproducibility. So the system needs to be accurate enough for the use case where it is being used. Third requirement is privacy and data governance, which includes respect for privacy, quality, and integrity of the data, and having access to the data to the proper authority as well as the data owners. The fourth requirement is transparency. That includes interpretability, traceability, explainability, and communication of the trade-off that has been made in the design of the system. Fifth requirement is diversity, non-discrimination, and fairness, and that includes avoidance of unfair bias, accessibility, universal design, making sure the design consider all people of the world, and also stakeholder participation. That means the system should design while including the opinion of the stakeholder. Sixth requirement is societal and environmental well-being, and that includes consideration for sustainability and environmental friendliness, and consideration of impact on the society as a whole and democracy. And the seventh requirement is accountability, which includes auditability, minimization of harm, and reporting of negative impact, and trade-off and opportunity for redress, which means if something goes wrong, what the people will do, who to reach to fix this issue. And these 7 requirements need to be continuously monitored and evaluated throughout the life cycle of the AI process. It's not that you just do the assessment once and you are done, because each time there is a change in the system, each time there is a data set change, say ChatGPT versus version 3.5 versus 4.0, there is a change. So we need to reevaluate and making sure that it's satisfying all the requirements. At this point, we can probably already see some of the requirements that are not met by today's Gen AI. I'll give some example. ChatGPT's monthly carbon footprint is equivalent to 260 transatlantic flights. Now, ChatGPT definitely has a lot of positive influences in the society. However, this particular application is probably not mindful about the sustainability and environmental friendliness, because it's emitting a lot of carbon on the environment. Here is an ad that was spotted in a bus stop, and it's saying, stop hiring human, the era of AI employees here. And I think that it is not considerate about the impact on the society and democracy. And here is another example. A 14-year-old committed suicide, which was prompted by a chatbot. And this is an example where the AI system was unable to meet the technical robustness and safety requirement. Clearly, the developer failed to put safety guardrails to stop such a behavior ahead of time. And probably they didn't anticipate this kind of usage. And it's the time when we want to see the process of science fiction that help us to figure out or at least analyze these whether our AI system is meeting these requirements. So now let's see how the inspection process works. Here is this inspection process in a nutshell. We have three phases: setup phase, assess phase, and resolve phase. In the setup phase, we try to verify preconditions, including some initial questions such as who requested the assessment, who are the stakeholders, why they are requesting the assessment, whether it will be used for sanction, or is that a government mandate, or is it are they doing it for their own development process, IP conflict, the legal admissibility of the assessment process, and we also want to make sure that there is no conflict of interest. And based on our understanding of the system and expertise needed, then we form a team of multidisciplinary expert who has the needed expertise to assess the system. For example, if the system is in healthcare AI, we need to make sure that we have the doctors with the proper expertise, we have the ethicist, we have the legal expertise, we have AI experts or system experts. We need to make sure that our team of experts has representative of all stakeholders as well. And then we try to form, define and agree upon the boundaries and context of the assessment. AI system cannot be assessed in isolation. We must have to consider the context where the system will be deployed and its use in the system. And then we move to the assess phase, where we start by analyzing socio-technical scenario. What it means is that we need to describe the aim of the AI system, who are the actors, their expectation from the system, how they interact with the system, how the system influence their decision-making process, the processes, the technology being used, and the entire context. Through this discussion with the stakeholders, developers, and the expert, we try to identify ethical issues and tensions that we can see in the usage or use case of the system. And we try to then map those identified issues and tensions through to this trustworthy AI principles that we just discussed, 7 requirement and 4 ethical principle. And then we also try to go ahead and collect evidences for different claims that has been made about the AI system. We also try to collect evidence base to support some of the issues that we identified. We try to analyze the code if the code is available, the data set if the data set is available. We try to understand if there are paper or test result. We try to analyze them, and we try to understand based on all the evidence we have, what are the ethical issues and tension that can arise in the use case. And it's a repetitive process. Through the repetition, we try to finalize the issues and tensions, and we try to sort them based on their priority, impact, or influence factor. And after the assess phase, we move to the resolve phase, where we provide recommendation. We describe the identified issues to the stakeholder and how to resolve them if we find any solution. And then we make recommendation on whether this system should be used or at what condition or in which cases and so on. Throughout the process, we maintain a protocol document, which basically lists everything that we do from the start to the end of the process. And the purpose of the protocol document is also to share it to any other stakeholder if needed for future assessment as well. Now, let's look into an example use case. Imagine that there is an AI system that has been designed to automate essay grading in high schools. This Gen AI would analyze essays written by students and it will assign grades. This is a hypothetical use case. I am presenting it just to give you an example of how the inspection process would work. Now, the goal or aim of the system would be, say, to reduce the burden of the teachers and probably to make the grading easier and grading more consistent. Now, for this particular project, in the setup phase, we need to assemble a team. We will assemble a team of relevant stakeholders, developers and the users, experts of AI, ethicists, legal, policy, and domain expert as well, where the Gen AI will be applied. So in this case of education, the assessment team would include AI specialists, engineers, educators familiar with the essay grading rubrics, students and parents, because they'll be impacted by the use of the AI, ethics expert, school authority, and legal experts. Then the team will discuss with the stakeholders about their goal, like why they want to bring this AI system. It could be, saving money, as in the Texas case. And then we'll set up the boundaries of the assessment and the goal of the assessment based on the discussion with the stakeholder. We'll establish the protocol document outlining the assessment goals and boundaries. Who are the actors, the aim of the system, and so on. Now, in the assessment phase, we analyze the socio-technical scenario or uses scenario. Here we'll evaluate how the Gen AI system will interact with the users and impacts the decision-making process. We'll identify potential risk related to biases, fairness, transparency, IP conflict, data privacy, security in the Gen AI project. And then we'll align those identified issues with the 7 requirements of trustworthy AI and 4 ethical principles that I talked about. And then we will ascertain if the Gen AI project adheres with those trustworthiness principles. And if not, we'll discuss that in the issues being identified. So in this case, for the Gen AI essay grading, the team will examine how the Gen AI interact with the teachers and the students. Does it provide clear feedback alongside the score? Can the teacher adjust the score if they disagree with the AI evaluation? Can there be any confirmation bias? Confirmation bias is when an user of AI tend to just agree with whatever the AI says. It could be because of fear that if they disagree, something bad will happen, or it could also be due to tiredness or fatigue. They just don't want to review what the AI is generating. Can that happen? And team would also delve into the Gen AI training data, such as the essays with assigned grade, how it is scoring those essays in the scoring algorithm, how it evaluates different aspects of writing style, such as grammar, structure, argument clarity, and so on. And then based on this discourse or discussion, we'll identify ethical, technical, and legal issues. Some potential risk would be identified. For example, we need to make sure there's no biases. Does the training data favor a particular writing style or background style? Can the teacher understand why the Gen AI assigned a particular grade? Would the Gen AI disadvantage students from certain demographic due to biased data? And then can it handle exams from special needs students? And if those are not graded by AI, but graded by human, will that sacrifice fairness? Because some will be graded by AI, some will be graded by human in those scenarios. How the students' long-term learning and teaching and teachers' long-term grading skill will be impacted by the AI. And finally, would it be cost-effective or carbon efficient? So, by answering these questions and analyzing the use case more, we would identify potential misuse and, fairness, transparency, robustness, safety and security, and well-being. So all the 7 requirements that will go through and figure out whether the AI system for grading essay is fulfilling those, and the cases where it is not fulfilling will identify them and communicate with the authority. So in the result phase, based on the assessment, we'll propose solutions to mitigate risk and enhance trustworthiness. And then we'll communicate the findings and recommendations to the stakeholder in a comprehensive report. Here is example recommendations. Based on the assessment, solution might look like that we suggest to retrain the GenAI with more diverse data set of essays. We might suggest that implement a human in the loop system where teachers will review the AI generated scores and provide final grades. We may suggest that develop a transparent explanation system that shows the teachers how the GenAI arrived at its evaluation. And then we might suggest that the school should also include students and the parents in the development and the deployment discussion so that they know that their grades are being evaluated by AI and how. And we also want to, we may also suggest that the authority should educate the students on the working of the AI system so that they can also improve on their exams, knowing how the AI system works. Okay, so that was my hypothetical example. Now we need to pay close attention to the following aspects, that there is no data biases. We need to assess the training data for potential biases that might lead to discriminatory outputs. We need to evaluate how the AI arrives at its results and ensure that users understand its reasoning. And we also need to identify potential misuse cases and propose safeguards. So a popular AI startup, Anthropic, they are popular for their effort to be more reasonable and trustworthy. And they have developed a tool called Clio that analyzes the prompt that user give and clustered them and identify misuse ahead of time so that they can stop those users or take steps. So that is an example of how AI developers can take steps to be more mindful of the usage of the AI. So I'm going to share some of the projects that I was personally involved in that we have assessed through inspection. One was to use AI for predicting cardiovascular risk, machine learning as a supportive tool to recognize cardiac arrest in emergency calls. It was happening in the context of Copenhagen. Deep learning-based skin lesion classifier, and then deep learning for predicting a multi-regional score conveying the degree of lung compromise during COVID-19 patient. Some of the ongoing work is trustworthy AI-based prognosis tool for predicting patient outcome in acute stroke. Explainable AI for monitoring acoustic features extracted from speech to help patient with bipolar disorder and depression. And then assessing use of GenAI for 808, and it's a project that is happening in collaboration with University of Toronto. So as you see, we have done some real world we have assessed some real world project using inspection, and some of these projects which are already finished, we have shared the lessons learned as in the form of publication. I'll discuss one lesson learned from each of the first 4 projects, which are already finished, just to share some of the insight. So for the first project, that was AI for predicting cardiovascular risk. It was a project that was already deployed, and we assessed it under NDA or IP constraint. So the lesson learned was that assessing already deployed project under NDA or IP constraint is often hard. because it limits the access to data, algorithm, and the process. And it also limits our ability to share the assessment results. For the ML to recognize cardiac arrest in emergency call, the lesson learned, one of the lesson learned was that if the development does not include all stakeholders, in this case, the emergency responders or the nurses who will be using the system, trust will be limited and it can impact the result in real world setting. And it may not match the experimental setting results. So what happened was that the system was showing higher accuracy in the experimental setting, but when they deployed that in practice, there was no accuracy improvement, and that's because the users were not present when the system was designed, and they had lack of trust in the system. For the deep learning-based skin lesion classifier, it was in the co-design phase, so the system was designed and we were involved in the discussion. So one of the lessons learned was that including different viewpoints of domain expert has impact on the overall design of the system. And goal of different stakeholder can be different. For example, say the general physician might want to reduce the overdiagnosis of skin cancer, and the dermatologist might want to reduce the mortality rates. So their goals are different. And the developer might want to make it explainable. So goal of different stakeholder might be different on the project. And in certain cases, the definition of fairness might also change. In this case, people who have more skin cancer are usually the people with fairer skin, and the data set was also heavily biased towards those skin because they are the population who experience skin cancer more. So in this case, the definition of fairness might change because those are the population who are experiencing skin cancer more. So the data set was more heavy on that side. For the fourth project, deep learning for predicting multi-regional skin lung compromise score for lung compromise for COVID-19. One of the lessons learned was that urgency during the design of an AI may lead to ethics oversight to be waived because there was an emergency. They didn't consider all the standard ethics oversight that they usually do in other cases when there is not an emergency. So those were one lesson learned from each of the project. To the assessment, inspection has been listed as one of the tools or metric for trustworthy AI by OECD, which is one of the recognized organization for policy advisory. And we also got recognition from ISSIP for our service on analyzing or assessing trustworthy AI. There are over 28 labs around the globe now that are affiliated with Cinespection, and similar number of institutions across the globe that are affiliated with Cinespection. So we have quite a bit of people who are interested and involved in assessment process for ensuring ethical AI. And Cinespection is also being taught as part of master courses in healthcare informatics at several universities. We have several resources like papers, publications, and talk. You can look for those resources in the www.cinespection.org. We also have an upcoming tutorial in IEEE CHI conference in May in Santa Clara. And feel free to reach out if you're interested and join the Cinespection initiative. We have a LinkedIn group on Cinespection initiative. So that concludes my talk, and then we can start the discussion.